Look closely at the world around you in Uganda, the roundness of a chapati, the face of an ngoma drum, or the wheels of a boda. These shapes are perfectly balanced because every point on the outer edge is the exact same distance from the center. This diagram shows the core anatomy of that shape. In the exact middle is the center. The straight line crossing from one edge to the other through the center is the diameter. The line from the center to the outer edge is the radius, and the boundary itself is called the circumference. There is a fixed relationship between these lines. The radius is always exactly half the length of the diameter. If you look at the metal spokes on a bicycle wheel, each spoke represents one radius extending from the center hub to the tire. For thousands of years, mathematicians observed a rule. If you divide the circumference of any circle by its diameter, the answer is always the same. We call this constant pi. It is approximately 3.14, or the fraction 22/7. Because this ratio never changes, you only need to measure one part of a circle to calculate all its other dimensions. Let's put this into practice. Imagine you are a tailor who needs to sew a ribbon around the edge of a circular tablecloth. To know how much ribbon to buy, you need the circumference. Our tablecloth's diameter is 14 centimeters. The formula is circumference equals pi times diameter. Using 22/7, we multiply by 14. Simplifying by dividing 14 by 7 leaves 2. 22 times 2 gives a 44 centimeter circumference. This formula measures a one-dimensional perimeter. It tracks the total distance around the outside edge, like stretching a piece of string around the table and then measuring it against a ruler. Now let's look at the flat space inside the circle. To find how much surface a shape covers, we calculate area. A 14-meter rope is our radius. To find grazing space, use area equals pi times radius squared. Remember, radius squared means multiplying by itself. 22/7 times 14 times 14 simplifies to 22 times 2 times 14, totaling 616 square meters. We record this in square units because it represents two-dimensional space. Squaring the radius is what allows us to account for the entire surface within the boundary. Consider this ngoma drum. If we need the surface area of the leather drumhead, but we only have a diameter measurement of 42 centimeters, we have to adjust our approach. Pause the video here. Using 22/7 for pi, find the radius first, and then calculate the total area. The area formula requires the radius, so we divide the 42 centimeter diameter in half, giving 21 centimeters. Applying the formula, 22/7 times 21 times 21. Simplifying leaves 22 times 3 times 21, equaling 1,386 square centimeters. Always verify your starting measurement before you begin. If you are given a diameter but need the area, you must find the radius first. Let's look at a final problem. A metal worker is cutting a manhole cover. He knows the circumference must be exactly 132 centimeters, but he needs the surface area to select the right amount of metal. We can find the area by working backward from the circumference. We know 132 equals 22/7 times the diameter. By rearranging this, we find that the diameter is 42 centimeters. Following our previous rule, we divide that diameter by 2 to get a radius of 21 centimeters. Now we use the radius in our area formula. Pi times 21 squared gives us a final surface area of 1,386 square centimeters. Solving these problems is a matter of sequence. Once you use the circumference to find the radius, you have the exact measurement required to determine the total area. To keep the formula straight, remember these two phrases. Cherry pie is delicious, for circumference equals pi times diameter, and apple pies are 2, for area equals pi r squared. Notice the number 2 in each formula. For circumference, which measures a one-dimensional line, the 2 stays at the front. For area, which measures a two-dimensional surface, the 2 is an exponent. From measuring the rubber for a bicycle tire to calculating the land inside a circular crawl, these formulas allow you to measure the curved world with precision.